Hello students, in this video we will do Pythagoras theorem using the concept of similarity of triangles and will solve some questions related to it. Now first of all, Pythagoras theorem: in a right triangle the square of hypotenuse is equal to the sum of the squares of the other two sides. That means we have to prove that in a right triangle, the sum of the square of two sides of a triangle is equal to the square of the hypotenuse of a triangle. Now suppose triangle ABC is right angled at B, then we have to prove that AC square is equal to AB square plus BC square. Now first of all, we will draw a perpendicular from B on AC. Suppose BD is perpendicular, to draw BD perpendicular to AC. Now, as we see here, we have to find the sum of AB square plus BC square, and that will be equal to AC square. Now, first of all, we will find out the value of AB square. For that, we will take two triangles which has AB as their side and then prove that those two triangles are similar. Now if we see in triangle ABC, AB is side of triangle ABC and ABD. ABD. Now, so we will prove that these two triangles are similar. Now, in triangle ABC and triangle ABD, angle ABC is equal to angle ADB, and that equal to 90 degree. ABC is equal to ADB and both angles are of 90 degree as BD is perpendicular to AC. Now, as we see in these two triangles, in triangle ABD and ABC, angle A is common angle. So we can say that angle BAC is equal to angle DAB, and this angle is common angle. Now that means that triangle ABC is similar to triangle ADB by angle criteria of similarity. And if two triangles are similar, then their corresponding sides are in same ratio. And as we have to find the value of AB square. So from triangle ABC we will take side AB and its corresponding side in triangle ADB is AD, and that will be equal to, now we will take AB in triangle ADB and its corresponding side in triangle ABC is AC. On cross multiplying it, we will get AB square equal to AD into AC, and this is equation first. Now similarly, here we have to find the value of BC square. Now as we see here, BC is the side of triangle ABC and BDC. So we will prove ABC and BDC similar. ABC and triangle BDC. Now in triangle ABC and triangle BDC, angle ABC is equal to angle BDC and both are of 90 degree. Now angle C is common in these two triangles, so angle ACB will be equal to angle BCD. This angle is common. Now that means triangle ABC will be similar to the triangle. Now ABC will be similar to the triangle BDC by angle criteria of similarity, and that means again we have to find the value of B square. So from first triangle ABC we will take BC. Now its corresponding side in BDC is DC, and that equal to BC AC upon BC. Now this will give us BC square is equal to DC into AC, and this is our equation second. Now on adding first and second, now first equation in first equation AB square was equal to AD into AC, and second BC square was equal to DC into AC. So it will be AB square plus BC square equal to AD into AC, AD into AC plus DC into AC. Now in right hand side we can take AC as common, and this will give us AC into AD plus DC. And as we see in a triangle, this AD into DC will be equal to AC. So in place of AD plus DC we can take AC, and that means AB square plus BC square is equal to AC square, which we had to prove. So this is the proof of Pythagoras theorem. Now we will do converse of Pythagoras theorem. Now converse of Pythagoras theorem. In a triangle, if square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the first side is a right angle. Now suppose in triangle ABC, AC square is equal to AB square plus BC square. Now we have to prove that angle ABC is of 90 degree. For that we will do a construction. First of all, we will draw a triangle PQR, a right angle triangle PQR, right angle at Q, such that this PQ is equal to AP and QR is equal to BC. Now in triangle PQR, angle PQR is of 90 degree. So by Pythagoras theorem, we can say that PR square will be equal to PQ square plus QR square. Now that means PR square will be equal to, now PQ, here we have drawn PQ was equal to AB and QR was equal to BC. So in place of PQ we can take AB, and in place of QR we can take BC by construction. Now this is equation second. From equation first and equation second. Now if we see equation first, its right hand side is AB square plus BC square, and the right hand side of equation second is also AB square plus BC square. Therefore their left hand side will be equal. That means AC square will be equal to PR square. AC square will be equal to PR square, and that means AC will be equal to PR. Now in triangle ABC and triangle PQR, AB was equal to PQ, BC was equal to QR. This we have constructed by construction, and AC is equal to PR from equation third. That means triangle ABC is congruent to triangle PQR by side criteria of congruency, and that means angle ABC will be equal to angle PQR as corresponding parts of congruent triangles are equal. That means angle ABC will be equal to angle PQR was of 90 degree, so angle ABC will be of 90 degree, and this is the proof of converse of Pythagoras theorem. Now come to exercise 6.5. In question number first, sides of a triangle are given below. We have to determine that which of these triangles are right angle triangle, and in case they are right triangle, then find the length of hypotenuse. Now here the sides of a triangle are given to us, and I have taken them as A, B and C. Now A square plus B square, we will take the sum of the square of the two smaller sides out of the three sides given to us, and that will be 7 square plus 24 square, as 25 is greater than 7 and 24, and this will be 49 plus 576, and this will be 625. Now C square will be equal to 25 square, and that is also 625. Now as A square plus B square is equal to C square, so the given sides are sides of right angled triangle, right angle at with hypotenuse. We have to also find the length of the hypotenuse, equal to 25 centimeter. Now in third part, sides of a triangle are given to us as 50, 80 and 100 centimeter. Now first of all, we will take the sum of the squares of the two smaller sides out of sides ABC, and these are 50 and 80. 50 square plus 80 square, and that will give us 2500 plus 6400. This will be 8900, and c square will be equal to square of 100, and that will be equal to 10,000. Now here a square plus b square is not equal to c square. That means the given sides are not the sides of right angled triangle. Now in question number second, PQR is a triangle right angled at P, and M is a point on QR such that PM is perpendicular to QR. We have to show that PM square equal to QM into MR. Now it is given to us that PQR is a right angled triangle right angle at P, and PM is perpendicular to QR. Now we have to prove that PM square is equal to QM into MR. Now here we have to find the value of PM square, and PM is a common side of triangle QPM and RPM. So we will prove these two triangles similar to find the value of PM. One is QPM and another one is PMR. In these two triangles, now if you see here, if we take angle, let angle QPM is equal to X, then angle MPR will be equal to angle QPR minus angle QPM, and that will be equal to 90 minus X, as angle P was of 90. Now in triangle PMR, angle PMR plus angle MPR and plus angle PRM will be equal to 180 degree. PMR is of 90 degree, and angle MPR was of 90 minus X, as we have obtained earlier. So this is first equation and this is second equation. So from second we can write that MPR is of 90 minus X and plus PRM equal to 180 degree, and this will give us angle PRM is equal to X. This is equation third. Now in triangle QPM and triangle RPM, here angle QPM is equal to angle PRM from first and third. Now angle QMP is equal to angle RMP, as PM is perpendicular to QR. That means triangle QPM will be similar to triangle PRM by angle criteria of similarity. And as we know that the corresponding sides of similar triangles are in equal ratio, so here from the first triangle, if we take PM, its corresponding side in the second triangle is RM, which can be written as MR, and that equal to, if we take PM from the second triangle, then its corresponding side in the first triangle is QM or MQ, and that will be QM. And cross multiplication, we will get PM square is equal to QM into MR, And this is the proof of question second. Now in question number third, right angle triangle DAP is given to us, in which angle A is of 90 degree and AC is perpendicular to BD. Now we have to prove, first part is AB square equal to BC into BD, second AC square is equal to BC into DC, and AD square equal to BD into CD. Now here in first part we have to find the value of AB square, and AB is common side of triangle ABC and DAB. So in triangle ABC and triangle BAD, angle DAB, ACB will be equal to angle DAB. Now, and these two are of 90 degree. Second one, angle in these two triangles DAB and ABC, angle B is common. That means angle ABC will be equal to, here first of all ACB is equal to DAB, ACB was equal to DAB, and both are of 90 degree each. Now ABC, angle ABC and ABD will be equal, as this is a common angle. ABD are equal because these are common angle. That means triangle ABC is similar to triangle CBA ABC is similar to triangle DBA by angle criteria of similarity, and that means AB upon DB or BD is equal to AB upon BC, BC upon AB, and this will give us AB square equal to BC into BD. Now second part of question number third is same as question number 2. Now in third part we have to prove AD square equal to BD into CD. Now here we have to prove AD square. We have to find the value of AD square, and AD is the side of triangle DAB and CAB. Now first of all we proved that DAB is similar to CAB, and then by finding the ratio of the sides we can find out AD square equal to BD into CD. Now in question number 4, ABC is the isosceles triangle right angle at C. Prove that AB square equal to 2AC. Now ABC is right angle at C and ABC is the isosceles triangle. That means AC will be equal to BC. To prove, we can say that AC is equal to BC as ACB, or you can say triangle ACB is isosceles triangle. Now in triangle ACB, angle C is of 90 degree. So by Pythagoras theorem we can say that AB square will be equal to AC square plus BC square. Now from equation first, in place of BC we can take AC. So AC square and in place of BC we will write AC plus AC square. Now that means AB square will be AC square plus AC square from first, and that means AB square will be equal to 2AC square. Now in question number 5th, triangle ABC is isosceles triangle with AC equal to BC. If AB square equal to 2AC square, prove that ABC is right angled triangle. Now here AC is equal to BC and AB square equal to 2AC square is given to us. We have to prove that triangle ABC is right triangle. Now first of all, AC equal to BC and AB square equal to 2AC square. These two are given to us. Now AB square equal to 2AC square can be written as AB square equal to AC square plus AC square, and in place of AC square we can take BC square from equation first. Now as here AB square of one side of a triangle is equal to the sum of the square of other two sides of a triangle. That means by converse of Pythagoras theorem we can say that triangle ABC is right angled triangle and right angled at C. In question number 6, ABC is the equilateral triangle of side 2A. Find each of its altitudes. It is given to us that triangle ABC is equilateral triangle. So its sides AB will be equal to BC will be equal to AC, and that is equal to 2A. Now suppose AD is altitude from A on BC. In triangle ADB and ADC, angle ADB will be equal to angle ADC, and that is equal to 90 degree each, as AD is perpendicular to BC or AD is altitude on BC. Now AB will be equal to AC, opposite sides of a, or you can say sides of a equilateral triangle. Now AD will be equal to AD, common side in triangle ADB and ADC. That means triangle ADB and is congruent to triangle ADC by RHS. Now, if triangle ADB and ADC are congruent, that means BD will be equal to CD, as corresponding parts of congruent triangles are equal. And from this we can say that BD will be equal to half of BC, as BD and CD are equal. BC was of length 2A, so BD will be of length A. Now in triangle ADB we can apply Pythagoras theorem to find AD. So that will be AB square equal to AD square plus BD square, and that will give us AD as root 3A square, or you can say root 3A units. In an equilateral triangle, all the altitudes are equal. That means if BE is altitude on AC and CF is altitude on AB, then BE will be equal to CF, and that will be equal to AD. Or we can say that similarly BE will be equal to CF, that equal to AD, and AD was root 3A. So the measure of each of the altitude of the triangle ABC is equal to root 3A units. Now in question number 7, we have to prove that sum of the squares of the sides of a rhombus is equal to sum of the squares of its diagonals. Now suppose ABCD is a rhombus. Here we have to prove that AB square plus BC square plus CD square plus AD square, that is sum of the square of the sides of a rhombus, is equal to sum of the square of its diagonal. That means will be equal to AC square plus BD square. Now as here ABCD is a rhombus, So as we know, the sides of rhombus are equal. So AB will be equal to BC, and that will be equal to CD, and that will be equal to AD. This I have taken as equation first. Now, diagonals of a rhombus bisect each other at right angle. That means OA will be equal to OC and OB will be equal to OD. Also, AC will be perpendicular to BD. Now, OA will be equal to OC, and if OA is equal to OC, then those will be equal to half of AC. Similarly, OB will be equal to OD, that is half of BD. Now, also BD is perpendicular to AC. So in triangle AOD, we can apply Pythagoras theorem to find the value of AD square. Now AD square will be equal to OA square plus OD square. OA was equal to half AC and OD was equal to half BD in equation second and third. So from second and third, we can write AD square equal to half AC square plus half BD square, and that will give us 4AD square equal to AC square plus BD square. Now as sides of a rhombus are equal, so 4AD square can be written as AB square plus BC square plus CD square plus AD square. So in place of 4AD square, we can take AB square plus BC square plus CD square plus AD square, as AB equal to BC and equal to CD equal to AD, and that will be equal to AC square plus BD square. In question number 8, triangle ABC is given to us and O is any point on the interior of ABC such that OD is perpendicular to BC, O is perpendicular to AC, and OF is perpendicular to AB. We have to prove in first part OA square plus OB square plus OC square minus OD square minus OE square minus OF square equal to AF square plus BD square plus CE square. Now first of all, we will join OA, OB and OC. Now here, as we have to prove now here we will first of all we will find the value of OA square, then OB square, then OC square. Now value of OA square can be obtained from two triangles. One is AOE and another one is AOF. If you find the value of OA square from triangle AOE, then we will get OE square and AE square, and here OE square is in the proof whereas AE square is not here, so we will not take triangle AOE. Now in triangle, if we find the value of OA square from triangle AOF, then we will get OF and AF, and OF and AF are in our proof, so we will take triangle AOF. So in triangle AOF, angle OFA is equal to 90 degree. So we can say OA square will be equal to OF square plus AF square, and this is our equation first. Similarly, we will find the value of OB square from triangle ODB, and that will be OD square plus BD square, and value of OC from triangle OEC, and that will be equal to OC square will be equal to OE square plus CE square. Now on adding these three, we will get OA square plus OB square plus OC square equal to OF square plus AF square plus OD square plus BD square plus OE square plus CE square. Now we can adjust these according to the question. Now here OA square plus OB square plus OC square was in our left hand side, and then OD square, OE and OF are also on the left. So we will take OF, OD and OE square on the left hand side of the equation, and that will be equal to AF square plus BD square plus CE square, which we had to prove. Now in second part, we have to prove that AF square plus BD square plus CE square is equal to AE square plus CD square plus BC square, BF square. As we have already obtained the value of AF square plus BD square plus CE square in proof of first, so we will use the proof of first to prove the second part. Now from proof of first, AF square plus BD square plus CE square is equal to OA square plus OB square plus OC square minus OD square minus OE square minus OF square. Now on writing OA square and OE square together, on taking OA square minus OE square together and OB square minus OF square and OC square minus OB square, OC square minus OD square together, we will get the right hand side as AE square plus CD square plus BF square by Pythagoras theorem, and that is the proof of the second part.